So hello, good day once again. Let us continue to our discussion. And for this session, we will be discussing about operating system structures and some other related topics. So to the main purpose where we need to understand the operating system structure is that the question is how an operating system is put together. So the purpose of this lecture is to understand some different simple structures of operating system and how it was created and as much as possible give you an understanding of the current structure. So this one, the first one here is the simple structure of an operating system. So if you can see here, we have an application programming, which is the upper layer, followed by the resident system programming, the MS-DOS drivers, and random access memory BIOS device drivers. See, in this case, in this simple structure, and this is an example of an MS-DOS structure, you can see that ROM BIOS device drivers is more related to the hardware part. And the MS-DOS drivers or desk operating systems who's directly connected to the hardware can access immediately to the hardware. And what is weird with this structure is that the resident system programming or your operating system equivalent to your operating system kernel can directly access your uh, read-only memory basic input output device drivers. And look at this one, and even your application programming part or the application layer has also access to your device driver BIOS. So uh, this structure is much complicated, and the disadvantage of this one is that if you allow access for the application programming part to the hardware, is that you can it's not a good management between the other resident system programming and the device drivers also. So the current structure is not necessarily the same with this one. And the second structure is the monolithic structure. The monolithic structure is that you can see it's almost similar with the simple structure, but here we emphasize that there is a group of kernel here. These three major layers is already part of the kernel, but there is a user, the shells and command compilers and interpreter systems library, and below that is your kernel. Then your kernel has actually access to your thermal controllers, device drivers, a device controller, and memory controller. So if you can see here, the kernel is actually divided in three major parts in the middle, but there is a system called interface to the kernel accessible by the upper layer. And the lower layer is kernel interface to the hardware, which is a direct access of the different controllers, which is directly also connected to your hardware. So the monolithic structure, if you can see that the kernel is actually a big bulk of program grouped together, but somehow divided into different major functions of the kernel. And they have provide access to the upper layer and the lower layer. So the monolithic, from its words, it's one major chunk of program. Uh, in contrast to that one is we have a layered structure. I didn't have title, but this is a layered structure. In the layered structure, each the operating system is arranged into layer where layer 0 is hardware and the layer n of the layer n is the user interface. So the advantage of this layer is that compared with the simple structure is that the upper layer has no access to the hardware part, and the hardware part is only accessible to the next layer. The importance of the layer is that the separation of the different functions in each layer, and each layer can only access on the upper side and on the lower side. That means you don't have a direct access from layer, for example, 3 to layer 1. So you need to go through into another layer. The advantage of this one is it actually separates different functions, and if there are problems with that particular layer, only that particular layer will be resolved. Or if there is an improvement to a certain layer, it will not somehow touch the other layers. That means if you will upgrade your hardware, that means only the hardware part will be upgraded, and it has only some adjustment on that particular layer and the access to the next layer. What is the disadvantage is that somehow it takes time to to move into another layer even if you can only supposed to be directly access to other layer. But that an example of an operating system that used the layered structure is the Windows 2000. If you look at this one, although we described earlier that it's a layered structure, but here if you can see that there is a hardware abstraction layer and there's a system services layer, and it looks like a monolithic structure, but somehow there are some layer on other parts and the other parts are not. So the ideal example of the layered structure is the one previously presented, but this one is an adoption of a layered structure in Windows 2000. What makes this a layered structure is that, example, the process manager has no direct access on the hardware abstraction layer. It will go into Windows 2000 kernel. But the I/O manager has a direct access to hardware and the system services. But on the graphics side is that the graphics has the direct access with the hardware layer, but somehow the system services cannot directly access with the graphics device driver. So it's still a layered structure based concept. Another is that this is a Unix, this is a Windows 2000, this one is the Unix layer structure. So somehow they are almost the same with how the Windows 2000 has been arranged, but the idea is still the same. We have each layer. This one is somehow similar with monolithic structure. The first, the structure wherein there is an interface between the hardware part and there's an interface on the user side, but somehow this group actually of set of major parts of your kernel is also accessible to a certain layer on your hardware. We have the microkernel. The microkernel is to address some of the concerns of the bulk structure of the um, uh, layered structure or the monolithic structure. So here, it creates a microkernel and some of the system services are actually accessible at the user mode rather than on the kernel. If you've observed on the previous structure, there is a separate layer for a kernel intended to interface with the user applications or the user mode. But here, some of parts of the kernel were already loaded into the user interface side. What is the problem with this one might be on if there is a problem with one application is that it can affect that user application side. What is good with this one is that some of the functions of the kernel is passing in through the user mode part, such as, for example, there's a virtual memory, the device driver is on the user mode interacting with your client programs. So somehow it mixed in the different drivers on the user side, and the microkernel is, or the kernel mode actually on the operating system is separated. Another is the modular structure. For me, the modular structure is currently adopted most of the operating system as of now. Here is, they are almost similar with the microkernel, but here the core kernel is on the center and all of the parts can be accessible within the core kernel. And outside of this one, which is the layer part, is part of the user interface. So here, um, the different groups of programs in your operating system has access to the core kernel, and these different parts also uh, operating system can be accessed outside of the user interface. So what is the advantage of this one is that if you there is a separation of the work, but a certain module is actually focused on a certain support functions for your applications that is running. So and they have all access. That means there is a common functions for all operating system, but all of the other related functions can access on this one. What they did on the modular structure is that they divided the system into modules and group these functions so are common to all of the modules and make it into a core kernel. Uh, so another interface in virtual machine, each process seems to execute on its own process with its own memory device. So uh, this is only a background about what is also the structure if there is a virtual machine. So sa virtual machine kasi parang it runs into the upper layer, but it acts also somehow something like similar to separate machine. So another is MS-DOS. Now, virtual machine is example if you're running a DOS application, which is the physical user part, and it's also running on another operating system, which is the physical machine. And there is also a virtual machine on your Java application. So there is a when there is an operating system here, and your program is actually having their own interpreter just to run part of the machine program that you are running on the Quest platform. Why we include this virtuality? Because it already exists in machines and it runs on the side of the outside of the operating system as if it's a different type of user. Okay, so I hope that you've understand. I've summarized that the focus of this lecture is to take up the different structures of an operating systems from simple structure, monolithic structure, the microkernel, the layered structure, and the modular. And I hope that you can differentiate each of them for the assessment.